My name is Emerson Garnett. I'm a principal at the firm, and I'll be your host as we get started today, before handing it over to Daniel to lead the conversation. For today's session, you can expect we'll begin with some brief introductions of the two speakers. From there, we'll move into a fireside chat covering three key themes: the future of commercial space stations, the evolving role of public-private partnerships in space, and the geopolitical tailwinds shaping this new frontier. Finally, we'll open the floor to audience Q&A with about 15 minutes reserved at the end. Please don't wait until then to share your thoughts and questions. Feel free to drop them into the Q&A section at the bottom of the Zoom. So with that in mind, let's get started with the intros. AC Charania currently serves as Senior Vice President of Space Business Development at Xenopower and is also an advisor to Balerion Space Ventures. He previously held the role of Chief Technologist at NASA, where he helped shape the agency's strategy for future space exploration. His career spans leadership positions across NASA, Blue Origin, Virgin Galactic, and SpaceWorks, and he's been deeply involved in shaping national space policy. Some of you may remember our webinar with AC, in which he shared valuable insights on what NASA is looking for from the commercial market today, and we're excited to build on that conversation and dive deeper into the future of space. Up next, I'd like to introduce Daniel Kleiman, general partner at Balerion Space Ventures. Daniel's built a strong track record in early stage space investments and has been instrumental in driving Balerion's vision, funding the infrastructure and applications that will unlock entirely new economies beyond Earth. So today, Daniel will serve as our moderator. He'll guide the discussion, both with audience questions and some of our own. And a big thank you to everyone who submitted questions in advance. Please continue to do so throughout the conversation. I'll make sure that we can get to them either live or at the end of the session. So with that in mind, I'll hand it over to Daniel to guide today's discussion. Thank you.
Thanks so much, Emerson. AC, great to see you, and looking forward to seeing you tomorrow in person, which should be fun. When you joined as advisor, we were incredibly excited because of just your breadth of knowledge covering just so many different parts of what we define as the value chain of space, and just a vast range of technologies that are now investable. I'd love to sort of start with you providing us with a little bit of insight as to how you think about these different capabilities, these different parts of the value chain that are investable, and sort of what's changed from when you first started in the space economy until today.
Yeah, no, thanks, Daniel. Thanks to Emerson and the Balerion team. Awesome to support you all and continue supporting you as we're trying to think about what's happening. So I've been trying to think about what's been happening since I was an undergrad 25 years ago, when I started in commercial space back then, which only saw a few of you back then 25 years ago. So I think my framework to think about this is to decompose, to look at the value chain in terms of, as the Balerion team calls it, but then I take another look at it in terms of the various component technologies that supply this value chain. So from launch, in space services, planetary kind of planetary surfaces, et cetera, orbital, and then utilities, power, these kinds of things. So I think of that, but I also look at the customer bases from the government side or users on the commercial side for these kinds of services in the value chain. So that's kind of where I think about it. A good, when I was at NASA, one of the things we did actually, which I probably haven't talked about, is we did actually update the NASA technology taxonomy. So NASA actually more than a decade ago realized, how do we talk about technology? And so they actually have developed and publicly available a technology taxonomy that breaks these technologies into 17 different components. So and that includes things like launch vehicles, but also in-space services, power, AI, autonomy. And I actually use that framework of the 17 to 18 different technology categories in the NASA technology taxonomy. I'm probably biased to NASA since I used to work there, of a framework of how to break them out. And so if you look at that taxonomy, there's actually been a lot of neurons spent to decompose those 17 areas into subcategories of areas. And so I look at that technology taxonomy on one axis of the 17 to 18 different categories and subcategories, and then I look at the commercial, government, and international customer bases for those technologies. Um, and specifically, when I was at NASA, we'd look at the NASA interest of in those 17 different technology categories, and which one of them was NASA investing in, or commercial industry, which one were gaps. So for instance, let's say quantum. In the quantum realm, NASA has an interest in quantum computing, but probably more of an interest from my perspective in quantum sensing, because that impacts the NASA mission. So once again, all quantum computing and quantum sensing were in these technology areas. For the NASA side, the other axis of demand, that sensing, I could see a lot more interest sometimes than computing. At NASA was kind of following what was happening in computing, but really interested in advanced IMUs, advanced quantum sensors, those kinds of things. So I think, to answer your question, I look at the value chain, but then I actually use something we all can use, which is the technology taxonomy that when I was at NASA, I kind of updated to add certain things, including AI. And I use that technology taxonomy framework to look at where does this fall in, and then use the other axes of customers or demand or missions to help them like track down where things might be more important. So
Got it. Yeah, and I think that last part is definitely, I think the audience would be interested in learning more about sort of what's more important based on the sort of relevance of the customer base today versus in the past, and where sort of that maps on
yeah.
across the different technology
And,
stack.
yeah,
Um,
and so those technologies haven't really changed. The one axis of technologies have not really changed. Things have been added, like large language models have been added, and things like that, or quantum technologies have been added since 25 years ago. I think what's changed is some of the mission drivers for the government, some of the mission drivers for commercial industry. Access has changed. Access to space has changed. It's much easier now. Computing has enabled, and microprocessor technology has enabled more capabilities. So those are the kinds of technology trends that I think have I see. Battery technology has improved, solar array technology has improved. So I look at those trend lines of those technologies from 20, 25 years ago: solar array technology, battery technology, propulsive technology, propulsion systems that didn't used to exist, reusability, and those trend lines now can impact maybe which of those technologies you might want to invest in. So
right. And in terms of, because you've played and been sort of in the role of both the government and the private sector throughout your career, how have you seen sort of the role of the government as a customer, and from sort of a investment lens, and sort of for looking for those pockets of opportunity across this sort of map that you're mapping out? What is the role of the US government and the different branches of the government to be sort of critical customers, and how does that sort of change over time during different market conditions or geopolitical environments?
yeah, just to give you a level set framework of the government customer many times has a mission dictated by the executive branch or Congress, and that mission, whether in a quadrennial defense review or an objective to land humans on the moon or get humans to Mars, is then decomposed into sub objectives. And the government customer is in the business sometimes of risk mitigation. So they're looking at achieving the mission, like at NASA, achieving the mission with with minimizing risk from using that approach. So I think that's always their mindset. It's we talk about the abundance mindset recently. That's been a big thing in all sorts of conversations. And sometimes the government customer does not look at it from that perspective. And you need to help them think about the abundance mindset, but they look at it from the risk minimization mindset of like, okay, I want to accomplish this mission with the minimum risk, or on the military side, I want to accomplish this military objective with the minimum outlay of resources because I want the option to use those in other places, or I want to do this lunar mission with humans with the minimum risk to the humans that are going on these missions. So I think that's the mindset of the government customer. The way they've gone about it has changed. In the past, it used to be more dictated. This is exactly what we want. Here are 1,500 requirements that you've got to meet. Here's the way you're going to meet these requirements. Here are the processes you will follow to meet these requirements. And now it's changed, where now it is, over the last 20 years, the mindset has changed to, instead of going with that approach initially, the government customer does look at, okay, is that a good approach? Or should we just put top level requirements instead of 1,500 requirements, maybe 20 requirements, and let industry come out with the solution of how to meet those requirements? And we can get into contract mechanisms, but there are contracts such as broad agency announcements, Space Act agreements that the government has used much more of, and specifically NASA, which I know the best in some sense, to just put out a top level set of requirements that industry can meet. So, for instance, we really, or the government, if speaking as a government customer, will not say, build a space station with all these modules and these technologies. It's more like, we want 30-day stays for 4 humans in low Earth orbit, and let us know how you will accomplish that. You will have to meet NASA safety requirements, but we're not going to dictate the technologies. We're not going to dictate the approach. We're not going to dictate the size of your space station, but we will give you these top level requirements with a set of conditions and how you're going to build the station. But we're not going to tell you, get into too much dictating the design, dictating the approach. And so that's that services model of top level requirements that are services. And the DoD sometimes has been more attuned to this than NASA. NASA over the last 20 years has actually been using this model for commercial cargo, commercial crew, human landing systems for crewed vehicles on the moon for Artemis, lunar terrain vehicles for lunar mobility. And now we're looking at this model also for commercial space stations to replace the International Space Station by 2030 or sooner.
So in summary, the U.S. government has made it sort of easier for the private sector to provide and play a more pivotal role in providing these capabilities to achieve our strategic goals. How much of the strategic goals, whether it be at the executive branch or at the top levels of government, is driven by our adversarials' capabilities and sort of nation-state competition that we're seeing in orbit?
Yeah, it is. It is. From the NASA side, specifically, once again, speaking of that framework, there are the 3 whys I think about when it comes to NASA. One is inspiration. NASA inspires the next generation of scientists and engineers. One is science. We want to know more about the universe and about how the solar system formed, how black holes formed, how life is formed. Is there life in the solar system? And then finally, national posture. National posture decomposes that pie chart of the national posture metric. You decompose into enabling commercial industry, but also our strategic objectives relative to the United States global competitors. And that's another reason we go out there. We just don't go to the moon to understand how the solar system formed from lunar samples that we get back. We're also doing it because our competitors are headed to the moon. And we believe is of national strategic interest to be on the lunar surface, to understand what is going on in cislunar space, to provide our commercial companies accelerants to help them get to the lunar surface, to land at strategic points on the lunar surface that have potential resources, or the option that we are not excluding ourselves from getting access to those resources, or someone stops us, whether legally or more likely operationally, from getting access to those resources. As a government entity, I like option space. I don't like when our strategic competitors reduce my options. And that's also true in cislunar space between us and the moon and around these 2 objects of the Earth and the moon system, but also on the lunar surface. And there are both technical missions that are happening, but also geopolitical teams that are forming. So we have formed at NASA, the United States government, the Artemis Accords,
Right.
to bring together more than 40 different nations under a shared set of values led by the United States. The Chinese have their own version of this, and an international lunar research station that they have less than 40, but they are getting people to sign on board for their set of principles in terms of lunar surface exploration, right? And so, whether we like it or not, I think there is a competition of hearts and minds, competition of missions that are going on, that is one of the three reasons of why we go to space: inspiration from NASA, science for NASA, but national posture, which is also probably a very high metric for the Department of Defense and Space Force, but also very high for NASA as an arm of the United States government. I don't view NASA as separate from the United States government. It is part of the United States government, and it's an all of government approach versus our strategic competitors. There's competition going on in the South China Sea, but there's also competition going on in cislunar space. Let us not, I would not, we should not forget that. And that
Right.
does drive investment. That does drive why we're going to the moon with humans. That does drive where we want to go with to the moon with humans. It does drive resources we might want on the lunar surface. The other thing I would tell your investors is the reason the government might invest in a particular capability on the moon is maybe the business case may or may not close, but as the government, I do not want to exclude the option of our companies and organizations getting access to resources. So even if resource X, Y, or Z on the moon may not close a business case, I, as the government, may want to secure that supply
Right.
because it's of national interest. And I may be willing to pay more for that supply of a certain material on the moon than I might otherwise, because our competitors are also trying to get to that resource. So
It's fascinating because if you go back to your framework and look at the different technologies and the customers, this national interest and competition, as things sort of heat up, you see the customer base and the opportunity become more apparent and timelines get pulled to the left across that technology stack that are relevant.
right.
Um, and I think we spent a lot of time collectively thinking about this, specifically with the retirement of the International Space Station, with
Right.
the competition and sort of commercial space stations. And so would love just for you to double click there and provide us sort of how you think about that relative to what we just discussed.
Yeah, I think the NASA Commercial Orbital Transportation Services model, COTS, which was the first about 20 years ago now, the first set of Space Act agreements, fixed price contracts with SpaceX and others to deliver cargo services to the International Space Station, then the follow on Commercial Crew Program, then the Human Landing System Program, then the Lunar Terrain Vehicle Program, now the Fission Surface Power, a 100 kilowatt fission surface reactor program. All of these are kind of fixed price contract type mechanisms where the government is asking for services. And now the same ecosystem of fixed price services kind of contracts is now coming to the International Space Station. We are now in a position where we are celebrating this year the 25th anniversary of the International Space Station being permanently inhabited. Incredible milestone for humanity, incredible milestone for the United States. But that space station is now nearing, and we've decided, NASA and the government, the United States government, have decided that there is an end state to the current International Space Station of around 2030, 31. Now, what's going to replace it? Now, the government, 25 years ago, the government would have said, well, we're going to replace the ISS with another government led program. Well, because of the success with SpaceX and others with these other models, people at NASA and the government are now confident that commercial industry, which has the capability, has the human resources, technical resources, and co investment funding to now take over space stations in low Earth orbit, and the government will just be a customer. It will have a services contract where it will want 30-day stays, longer stays for U.S. astronauts, and instead of dictating how the station looks, the power levels, the capabilities, it will dictate the services astronauts need once they're there and how safe those stations have to be in terms of meeting certain requirements. And so that's where we find ourselves, that this wave of the 21st century in the last 20 years of services based contracts for civil space are now entering the space station domain. And we are now looking at NASA has funded different companies, working with other companies to mature technologies and knowledge of how to build space stations, and has now looking at a new solicitation to look at design and development over the next few years of space stations, and prior to putting out a space station services contract. So the big end goal, the big TAM on the NASA side, is the phase 3 services contract they're now thinking about. That would come a few years from now. That would be the space station services contract for the next decade. You know, Now, before you get to that big contract, there's some design and development work, and that's the current phase. There's a draft RFP on the street. NASA's thinking about a final RFP over the next few weeks, and that would fund this interim period before you get to the full services contract for people to design and demonstrate, uh, get maturing their designs to a critical design review, their space station designs, paying for that, and then paying for 30-day demonstrations of a 4-person crew. So that's
Right.
what's currently on the table, that over the next few years, it's an awesome opportunity to demonstrate this human habitation commercial capability prior to giving out the full services contract. And NASA, over the last few years, has biased a little bit to having 2 providers.
Yeah.
And that seems to have worked well for many things, from both commercial transport of cargo to the International Space Station, commercial crew transport, as well as the Human Landing System program for commercial landers. So having 2 providers has kind of been an interest of NASA. And we may see that going forward on the commercial space station program, C3DO, as they call it now, in terms of this next phase of the program, looking at design development, uh, and 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 kind of experience from these providers. And so I think it's an awesome time, that, like for instance, for me, as I talk about the way we're doing, going back to the moon with Artemis, the way we're doing the space station, uh, demonstration and then operations contracts would blow the minds of people at NASA 25 years ago. Just blow the
Right.
minds. Both the contract mechanism, the technologies companies are putting in, the companies are putting in their own public-private partnership co-investments, and it's awesome to see. And it's like NASA is working with industry to build commercial human lunar landers. So obviously, if we're working with industry for commercial lunar landers with humans and NASA astronauts, we could definitely do space stations, right? So I think that's an awesome time, and it also helps NASA then invest into even more challenging missions onto Mars, to asteroids, to other places, do more science, where industry can take the heavy burden off, of NASA from running space stations. So
Yeah. No, it's thank you very much for that framework, and the way you think about that is fascinating. We've seen other companies in the category, whether it be SpaceX or Anduril or some of these other companies that have been really successful, have sort of built products quickly, iterated quickly, and delivered products to the US government that they think that they need, as opposed to just being reactionary. you know, do you see that approach to be successful in this specific category? What are sort of some of the risks that you see for companies trying to be the replacement of the ISS, and what's the best way to mitigate those risks?
yeah, I think the thing is you can have. I think another thing you see generally is this tension between systems engineering and iterative development, right? So NASA and industry, since Apollo was incredible, and NASA is an incredible muscle for detailed systems engineering of complex problems. A Manhattan project, an Apollo project, and the model we've used for many decades has been this very elaborate, very intricate systems engineering framework to bring different disciplines together. There's Over the last 20 years, we see another model, which is iterative development, that another way to attack this problem is, instead of optimizing every single systems engineering piece of the engineering supply chain, engineering design chain, I'm going to slowly iterative develop, test, and then slowly grow capability with that knowledge base. And that's been success. I think both models can be successful, but we see a lot of success over the last few years in this iterative development. And
Right.
then also, what I also recommend to companies is get a minimal viable product out there, right? When you put in a proposal to the government, there are various metrics the government uses to evaluate you. How is the idea, the technical idea you've presented in this proposal? How well thought out it is? Is it? What's the management team look like? What are the resources, facilities, people that you have in the company? What past performance have you done? What experience do you have in sending things to space, for instance? And so those top level criteria of your technical design, your team, your past performance, in these technology areas, I think, are the 3 kinds of metrics people use to evaluate a proposal. And so you could have a great, very intricate systems engineering based up design of your space station, but if you don't have the right team, you don't have the right facilities, you don't have the right investments in technology, and if you haven't done any demonstrations, that intricate, great design may be very brittle when it comes to winning a proposal. And so I think what will, and Andrew and others have, and SpaceX and others have realized an approach is make a minimal viable product, scale that up, get experience. And that does help to the government customer to give people confidence that um, these systems are capable and these are systems worthy of investing. So I think for me, it's in Silicon Valley, it's the dream and the team, but I also think about the dream and the team and the demo, right?
Right.
What do you have in the pipeline before the full scale system to demonstrate a capability? And I think some of the companies in the space station arena have locked that idea in terms of dream team, but also demo, and so we can get more into that as well.
No, that and it's amazing because as people think about investing in this opportunity set and in the category, having a framework of that is really helpful to understand how to de-risk because the assumption is there is going to be really long timelines, really long tech development cycles, and having almost like a force function within the government contract selection mechanisms to kind of weed that stuff out, I think is very should be more comforting to investors investing in the category.
Yeah, yeah. Because like the government in many of these contracts is trying to do a financial economic due diligence, right? So anything you can give them to provide them confidence, and that's where I think about the demos, you know, in space demos. Like when I was at previous companies, some of the engineering teams would come to me and say, "Hey, AC, we're thinking about this kind of solution, this subsystem, and we'll test it in a thermal vac chamber." Like, okay, we could do that. Can we actually put a little bit more money and send that thing to space? Because if we send it to space, our investors, our founder, will be even more impressed that, and we will have learned something, right? Yeah, putting it in a thermal vac chamber on Earth, going through the typical process, yeah, but if we take a little bit more risk and send that thing to space, just the process of integrating that subsystem on a launch vehicle, mission operations, getting data from the space environment, we will learn so much more. An example of this was when I was at Blue Origin. As we were developing the Lunar Lander program, we didn't really have a suite of landing sensors to land on the moon, but we had identified NASA sensors and algorithms. And one of my ideas was, along with a few others, why don't we take those sensors and algorithms and instead of putting it in a thermal vac chamber or testing it on a pickup truck that's driving away from a lunar landerscape, let's just put that on New Shepard, like the propulsion module, because that thing goes up to 100 kilometers. And we'll put the sensors on New Shepard. And as New Shepard is coming down, it's now our test bed as a lunar lander, basically, versus
Fascinating.
putting that on a helicopter. We could have put it on a helicopter and tested those same sensors and algorithms. And they eventually did that. But I was just like, hey, we've got a suborbital vehicle that's going to 100 kilometers, which is when these sensors would start activating on the moon at that altitude, 100 kilometers away from the lunar surface. Let's just use that. And that would buy down risks. That would give us experience in integrating sensor suites onto a platform. And so I always think about that of like the dream and the team of a lunar lander, but what's the demo on the
Yeah.
sensor side? And that was the idea with the New Shepard test on landing sensors at Blue Origin.
Yeah, yeah, absolutely. Now, going back to sort of your framework, I know obviously you're excited about space stations and that opportunity. What are maybe one or two other areas across the tech stack or the value chain that you think is really interesting from, a much larger customer today than was previously, a dynamic and characteristics that makes things, to be able to drive real returns from investor standpoint?
Yeah, I think for me is there's a lot of companies in the stack, and I think Balerion has done a good job in investing in several of these, looking at services and transport and compute and nuclear. And so I think about those things that have been invested in that can I take advantage of? And on the like let's say nuclear side, there's efforts for radioisotope and fission power systems that that will come online, and now how can people take advantage of that? When I was at NASA, I would ask people, so what's your Starship disruption strategy? Which is, if Starship is successful, how do you take advantage of that wave? And so I think about now, well, if nuclear power in space is successful, whether radioisotopes, nuclear batteries, or fission reactors, how do you take advantage of that? How do you take advantage of a 100 kilowatt lunar surface fission reactor that NASA is embarking upon landing by 2030, 31? If that's available, how can you take advantage of that trend? How can you take advantage of Starship? How can you take advantage of LLMs? Like ride these waves of different trend lines. So I look at the trend line of Starship, trend
Right.
line of batteries, trend line of nuclear power, trend line of AI autonomy. Okay, now I start making these trend lines, and Moore's law as well, and all of that. And then now I can see opportunities emerge in those 17 different technology areas, because some have already been checked off or companies that are addressing that, but some are not, because I couldn't until I had the launch and transport situation handled, if I had the power situation handled, if I have the comp situation handled. Now I can start enabling certain things. It goes back to what, when I worked for Jeff Bezos, he would think about relative to what Blue Origin was trying to do. If Blue Origin is successful and others, then you've created a foundation that others can form businesses around. And that's what I think about. Okay, maybe you don't want to solve the Starship problem. You don't want to solve the nuclear problem. A few of those have already are being solved, will be solved. And then how can I take advantage of these infrastructure plays? And are there any more infrastructure plays out there?
Yeah.
Transport in some sense might be a transport infrastructure play. Power is one, comms is one, but um, kind of surfaces or habitats is another one. And so I think that's another area that, with the NASA commercial LEO destinations program, C3DO, as they call it now, or in terms of this development phase, is an opportunity to sync up with a new infrastructure play. And companies like Vast are an example of that kind of infrastructure play that can take advantage of Starship, take advantage of Falcon 9, take advantage of Starship, take advantage of these power systems, take advantage of advanced comms, take advantage of reentry systems we now might have. There's multiple reentry companies out there globally, but if there's LEO habitats, now that starts making these reentry companies even more interesting and valuable,
Yeah.
right? So.
Awesome. No, I could go all day, but we've got a bunch of questions from the audience here, so we'll turn to them. Emerson, I know you've been forwarding them along, so I'll just start here at the top. What is, in your mind, the correct balance between industry and regulatory agencies, and how can we improve in that arena?
Yeah, I think that's a big thing. I think there is, on the regulatory side, the Federal Aviation Administration, the space piece of FAA that regulates launch and reentries. And there's been a conversation of, past that, how much does the government regulate activities? And that's an ongoing conversation with the government. I think it is to show, can commercial industry show to government regulators like the FAA and others, um, behaviors, responsible mission operations, authority, control over assets, and to bring them into mission operation centers and other things to show them how this is how we're going about it. And so, for instance, like let's say at Vast, I visited them, and you go to their incredible mission operations facility they've set up in Long Beach, and it's like, that's awesome for a government customer to come in and see that and say, oh, okay, you're doing your demonstration missions, and but you've developed a mission operations center that can handle both the demo mission and the full operational mission, right?
Right.
That gives a government customer confidence that, okay, someone like Vast is actually thinking long term. They're not just thinking about the initial demo mission, they're thinking about the full operational mission. So I have confidence, and yes, and I have confidence that they understand both their near-term demos, but the full operational system they can operate, control, have knowledge about, and then also that helps a customer who wants to use a vast space station also feel confidence of, like, in terms of they've invested in both the near-term demo but the long-term operational system. So I think about that in terms of the dream and the team and the demo, right? And so have you shown to the government customer you have the dream and you have the systems engineering design, you have the team, but you have also demonstrated operational experience, to give them confidence, because there are people in the government that want to work with industry and are more forward leaning, but you have to provide them evidence
Right.
that they can use internally. Once again, it goes back to risk minimization on the government side. There are people at the government that want to lean forward, but they need to prove to others in the government that risk is minimized by the design and the operations of these systems, to provide evidence, right? Uh,
Awesome.
so I think that's what I think about in terms of the regulator, and this also goes into conversations different parts of the government are having with industry about regulation of in orbit activities. So
Yeah. No, absolutely. And so next question here, where do you see sort of the biggest, quick wins or large near-term revenue opportunities where there's an overlap between commercial markets and national security needs, whether it be Earth observation, communications, just lunar propulsion?
yeah, I think one is definitely this $1 billion+ NASA is thinking of investing in for this middle phase of the commercial space station program. So I think that's an opportunity. So that's definitely one. Um, I think about Golden Dome, obviously. The Shield RFP is out on the street, in terms of getting the contractor communities in the gate, inside the fence, to start thinking about what is Golden Dome, what does this architecture look like, what are the companies that can provide services in the various technology areas for Golden Dome and the Shield solicitation. That's $150 billion right there. I do think about, there is Artemis 2, 3, 4, 5 on the NASA side to head back to the moon with humans. So I think that is secure to me. What happens after that on lunar surface is a place for people to talk to the government about, and I think those are opportunities. But I think about, how do you enhance Artemis 2, 3, 4, 5? What capabilities, power, mobility can you provide to the government to enhance that? The Golden Dome initial um, capabilities and tranches, but then how do you enhance those tranches? How do you take maybe baseline capabilities and enhance them? So I think those are opportunities that the government might want to take part of that investment, 150 billion, to look at. Not a large portion, because they need to feel the system, the maintenance of that system. Once that system is up, that will require care and feeding and maintenance. Is that an opportunity for people? I think about, how do you take advantage of 100 kilowatts on the lunar surface? NASA is going to move out, find contractors, one or two, to provide that lunar uh, fission reactor, but it's going to need, what are you going to do with that power? Are there interesting corollary businesses that take advantage of that power? So now I have Starship, I have a 100 kilowatt lunar surface reactor, I have Blue Origin's Blue Moon that can land 20 to 30 metric tons. How do I take advantage of this and form companies that once the development phase is over, the government is ready to invest in applications,
Right.
the application layer on the lunar surface? I think about I also think about an opportunity for Mars. That's maybe more difficult for some people to invest in, but there will be in the NASA budget a Mars wedge. One of the last things I ask people at NASA or some of the team that work for me is, how do you accelerate commercial public private partnerships for robotic and human exploration for Mars? Right. That's a question. And I think there's going to be funding coming up in the next few months and in the NASA budget for the next few years for a Mars wedge, for Mars payload development and Mars transport, focused on commercial public private partnerships. I think those are opportunities. Um, so I think Golden Dome, obviously, how do you take advantage of Artemis and the capabilities there? How do you take advantage of um, the space station kind of development program that NASA's embarking upon over the next few years, which are infrastructure plays? And then in that technology stack of 17 to 18 different technologies, which of them are being addressed by these programs, Artemis, Golden Dome, the Golden Dome architectures, uh, the commercial destinations program, and then
Right.
where can I apply kind of application layers on top of these things?
Yeah. And we've got time for one more question here, and then we'll wrap up. In the product taxonomy you outlined, what sector opportunity is the most underinvested in your mind, or the biggest untapped space relative to the opportunity?
I don't know. I think um,
Good question.
it's a very good question. I mean, it's like the $1 billion question, or VC question, and I think it changes. I think I look. What I was always curious about was when I was at NASA. One of my jobs was to like look in between the cracks of things people didn't see, weren't investing in, and that's what I was always interested in. Of like, okay, this mission director is funding this mission director is funding this, but maybe there's something in between that fell through the cracks, and is that a place to invest in and bring that up to senior NASA leaders to think about the government should be investing in here or working with industry. So I think about that in those 17 to 18 different areas. I mean, there's a lot of investment going on in all sorts of areas. So I also think about the timeline, and so my timeline at NASA was a little bit longer than the VC timeline. So I was thinking 10 to 15, 20 years out for the agency versus maybe a 5 year horizon. So I think within 5 years, I think about what is the future in 5 years, and that is Starship is flying, New Glenn is flying. We have one or more commercial space stations in operation as the ISS is about to be retired. We have landed humans on the lunar surface. We're about to land a 100 kilowatt surface reactor. Um, we have commercialized some cislunar comms. Golden Dome is up there. And so you start putting together this future, kind of think as a futurist, you put together these various futures. Our competitors are up there. Now, how do I take advantage of this situation? And are there gaps, in that 17 to 18 different areas? I think there's probably more in comms. I also think about material technology. A lot of these programs and projects need advanced materials. I think about, you know, if Starship, New Glenn, and commercial space stations like VAST are up there, how do I take advantage of that? What's the application layer on a VAST space station that's delivered by a Starship? You know, and now I can get to a space station through VAST and SpaceX. How do I take advantage of that? How do I put applications on that? So, once again, I leave it to all of you, but it's like I've got a vast space station launched by SpaceX or Blue Origin or others that has a Varda or other companies' reentry capabilities. Okay, now what's the application layer to pharmaceuticals, to advanced materials, to fiber optics? What's that application layer? And maybe I think part of the application layer to me is material development and also bioengineering. So I think about the application layer of material development, advanced materials, pharmaceuticals, whatnot, and then some kind of bioengineering kind of thing, which we're not investing in as much. But now that the application layer is upon us, how do we leverage that? And then I think about the services layer, comms and power. Uh, high bandwidth comms all over the place, power transmission, getting power to distributed nodes all over the place in cislunar space, and so that's nuclear and that's other forms as well. So, yeah.
Well, an awesome answer to a great question. Thank you so much. Emerson, we'll hand it back to you to wrap up.
Awesome. Yeah. Big thank you to UAC for sharing your vision, insights. I think that was an amazing conversation, incredibly valuable. As a reminder to everyone, today's session's been recorded. We'll be sharing the YouTube link with all of you shortly, so you can revisit it or share with colleagues. If you have any additional questions, please don't hesitate to reach out directly to me. My email is e.garnett@balerionspace.com. Also encourage you all to continue the conversation by connecting with both AC and Daniel on LinkedIn. Their links will be in the follow-up email after this concludes. And on behalf of Balerion Space Ventures, thank you again for joining us today. We look forward to staying in touch, and we hope to see you all at our next session. Until then, have a great day.
Thanks, AC. You're the best.
Thank you.
Thank you.